In this video, we're going to discuss how to find the mean or expected value of a discrete probability distribution function. Right. So what do we have? What do we have here? This is a probability distribution function for the number of cavities of adults aged 30 years old in the United States. Okay. So since this is a probability distribution function, this is not, this is not data that's coming from a sample, right? But what this is saying is theoretically that 12% of the adults age 30 in the United States, right? That's the population. That's the population is adults that are age 30 in the United States. That 12% of them have 0 cavities. 21% have 1 cavity. 33% have 2 cavities. So, using this information, we could answer questions like, well, what percentage of Americans aged 30 years old have 6 cavities? What would you say? Well, 0%, right? That's not included. So absolutely no one has 6 cavities according to this probability distribution function, right? Now we can always double check that this is a probability distribution function by adding up all the probabilities. And they should add up to 1. If we were to do that, we do see that these add up to 1. All right, so now let's find the mean number of cavities. Now, mean number of cavities, this is also called the expected value. So you'll see mean and expected value be used interchangeably. And the reason is because, the reason why it's called expected value is because that's basically, if we were to go out into the population, right, and the population right now is adults aged 30 years old in the United States. So if we were to go out into the population and observe someone, the expected value is how many cavities we would expect that person to have, right? So on average, how many cavities would you expect for a sample? So if you had a sample coming from this population, what would you expect the average to be, right? So that's what the expected value is. All right, so let's talk about how to calculate it. The formula for the expected value, I'll go ahead and write it down here. Expected value is written as E of x, right? The expected value, E stands for expected value, and then it's of x, meaning of the random variable x, equals, so mu is the population mean, okay? So mu and the E of x, these are the same thing. This means expected value. Mu means the population mean. Okay, so both these things equal the same thing, which is the sum of x times p of x. So the sum of the values of x multiplied by the probability of that x happening. Okay, so let's go ahead and add a row here where it's going to be x times p of x. So I'm going to go ahead and add this as a row. Okay, so this is basically what is this? This is basically I'm weighting every possible value of x by its probability, right, and then summing it up. And that'll tell us the mean for x. All right, so go ahead and multiply p times x. So that would be 0.12 times 0. So that's 0. 0.21 times 1. That'd be 0.21. 0.33 times 2. That'd be 0.66. 0.18 times 3. That'd be 0.54. 0.09 times 4 be 0.36. And lastly, 5 times 0.07 would be 0.35. Okay, so then sum up that row. Sum of this row equals, go ahead and plug that into a calculator and add up 0 plus 0.12 plus 0.66 plus 0.54 plus 0.36 plus 0.35. You'll get 2.12. All right, so what that means is if I were to go out and get a sample from the population, I would expect that the average number of cavities in that sample would be 2.12 cavities, right? On average, people in this population, so people that are age 30 years old in the United States, on average, they have 2.12 cavities. That would be how you would interpret this number.